Today, we are going to discuss all about nature of microwaves, prepared by yours truly, John Kenneth C. Abergos. At the end of the lesson, learner must explain briefly the nature of microwaves, cite and record examples of functional use of microwaves, appreciate the existence and role of microwaves in real world. Microwaves. Let's define first what is microwaves. Microwaves came from the word micro plus wave. Micro meaning small and wave meaning disturbance. All in all, small disturbance. What is microwaves? Microwaves is a form of electromagnetic radiation with wavelength ranging from 1 meter to 1 millimeter and frequencies from 300 megahertz to 300 gigahertz. In terms of position to electromagnetic spectrum, microwaves are generally shorter than the radio waves, but longer to infrared up to gamma rays with regards to wavelength. Microwaves are also referred to as far infrared waves, terahertz radiation, and ultra-high frequency radio waves. Let's discuss the history of microwaves. Microwaves was generated by James Clerk Maxwell in his theory now called the Maxwell equations in the year 1873. Maxwell first identified microwaves as a form of invisible light when he predicted that a couple of electric and magnetic field exist between radio waves and visible light, which should have shorter wavelengths. The image in your screen is the portrayal of James Clerk Maxwell. In 1888, German physicist Heinrich Hertz was the first to experiment similarities between radio waves and visible light using a spark gap radio transmitter. In his experiment, he concluded that radio waves demonstrates refraction, diffraction, polarization, and interference, just like visible light, and giving the notion of radio waves having sub-electromagnetic parts and division called microwaves. The image in your screen is the portrayal of Heinrich Hertz. Let's move on to the history of microwaves. The first microwave communication experiments was done using the Barkhausen coarse tube and a split anode magnetron in 1930. These instruments help radio researchers to propagate low-power microwave reading, which are the basis for electron signal transmission. Microwave propagation. Microwaves travel through line-of-sight paths but do not travel through ground waves. To the first Fresnel zone, microwaves can pass through building walls, good for readable signal reception. Microwaves are absorbed by moisture in the atmosphere, making rain fade a significant factor in microwave propagation. A challenge to microwave penetration under low frequency, as frequency attenuation requires higher frequency. Atmospheric gases also absorb microwaves as it passes through atmosphere, making it limited to some area in the Earth where accumulation of atmospheric gases are in high rate. Let's come to the microwave sources. Man-made sources. Microwaves can be generated with the use of the instrument called vacuum tubes. Vacuum tubes are comprised by a magnetron and gyrotron that let the electrons ballistically move with each other to create controlled electric and magnetic field to produce continuous stream of microwaves. And other man-made resources include field effect transistors, tunnel diodes, GaN diodes, and impact diodes, which all work and format electron movements to achieve the right angle of electromagnetic field for microwaves. Natural sources. All warm living bodies, unicellular and multicellular, produce and emit low-level microwaves depending on their temperature, which called the black body radiation. The sun and other constellations which consider astronomical radio sources also emits high-level microwave radiation. Cosmic microwave background radiation is another source of microwaves that fills empty space of the universe after an astronomical catastrophe happened. Functions and uses of microwaves. Communication. Microwaves technology is used for point-to-point telecommunications. Microwaves are used in spacecraft communication, television, internet data, and telephone communications, as microwave radio relays are able to transmit broad bandwidth of signal and allow frequency reuse. Microwave radio channels uses microwaves in multiplexing both radio and television programs. Wireless LAN and Bluetooth connection redirects with the use of low-level microwave signals. Satellite and military communications use microwave band such as C, X, Ka, Ku to avoid signal jam and data traffic. Navigation. Global Positioning System or GPS uses microwaves as specific bands of gigahertz to track down navigational signal, which includes location, temperature, files, and status of a certain device. Radar. Microwaves are considered a low beam radio waves can reflect device location, range, speed, and direction of movement drawn out in a scale reading of microwave frequencies in a vehicle or a cargo using radar. As microwaves, the main frequency used in radars, applications such as weather forecasting, air traffic control, and navigations of ships are made possible. Radio astronomy. Cosmic microwave background radiation emitted by astronomical radio sources such as planets, stars, galaxies, and nebulas are used in the study of radio astronomy. Radio astronomy is the study of galaxies and systems in universe using a large laboratory consisting of different radio telescopes installed to view various distance from the universe. Heating and power application. Microwave oven, which only work when plugged into an electrical sources, utilize small cavity magnetron to alter dielectric heating towards the food inside of a microwave. Spectroscopy and field of science. Microwave radiation projects electron resonance, a good point to study electrons under spectroscopy. For electrons at certain chemical systems, electrons at free radicals, and electrons to element ions, a study called microwave electrochemistry. Effects on health. Microwaves do not contain sufficient amount of energy to chemically change a substance found in the human body, but long-term exposure to microwaves can lead to risk of having carcinogenic diseases. The microwave auditor effects is another negative health condition resulted from too much exposure to microwaves. This causes damage to hearing center of the brains, which will lead to auditory malfunctions. Overexposure to microwave radiation can cause cataracts, as microwave heating denatures proteins in the eyes. Other health issues concerning microwave exposure are tissue damage and uncontrolled body heating. References: www.livesense.com, Science, NASA.gov, New World Encyclopedia, Prezi.com, Unibi, Darbel, and Science Daily. That's all for the nature of microwaves, and once again, good day.